Hello everyone. So today I am going to give a lecture on machine design, that is design of machine members 1. In that I have taken the concept design for strength. Now can anyone please tell me what is the strength? What is the strength of the material? If we want to know the strength of the material, what stresses we have to know? Okay. So, first of all let me explain about strength. So, strength is nothing but it is the first of all a property of a material. Okay. Here strength is nothing but it is the ability of the material to bear the applied load. So, here in order to design for the strength of a material, so whenever our design is nothing but we are in our daily life we are going to design so many mechanical components based on the strength itself, right. So, here I want to know the strength of the material. How can I know that strength of the material? Means based upon the conducting the experiments. So, then what type of experiments I need to conduct? So, I need to conduct based upon the universal testing machine. Okay. So, tensile test, compressive test and also shear test. So, based upon the different conducting the different tests, I can know that the strength of the material, how much load it can bear, okay, what is the how much strength it can bear. So, what is the ability of this material? So, I can know different types of the values based upon the strength itself. So, for that, so first of all we need to know the different stresses. So, that is a simple stresses in the design. We call it as the simple stresses. So, to know the strength of the material, so first one is tensile stress. So, then what is mean by tensile stress here? So, tensile stress, let us take one body or else a bar element. So, this is the bar element. So, here I am going to apply the two equal and opposite forces. Two equal and opposite forces I am going to applying on the bar. So, please all of you assume that what will happen if I am applying the two equal and opposite pulls on this material, on this bar element, what will be happening? So, immediately we all know that. So, here we are applying the two equal and opposite pulls. So, let us consider the L original length of the body due to the application of the changes. So, there may be a chances to increase the length of the body maybe in this direction, right. So, at somewhere somewhat internal resistance will be there. So, that internal resistance per unit area of cross section will be treated as tensile stress, which will be represented with the letter sigma T. So, therefore, sigma T equals to applied load divided by area of the cross section, that will be called as tensile stress. But here we also noticed one more point, that is the original length of the body will be elongated due to the application of the two equal and opposite pulls. So, therefore, here the changing length to the original length of the body, which will be called as tensile strain. So, strain will be represented with the letter epsilon. So, we are discussing about tensile stress, therefore, epsilon T is the tensile strain, that is equals to delta L by L. So, here we are able to identify the what is the tensile stress, what is the tensile strain, right. Now, is there any difference between this stress and strain? Yes, absolutely. Here we have the relation. So, all the materials having the one property that is called elasticity, right. So, based on the property of the elasticity of the material, whenever the stress is directly proportional to the strain, okay, there may be a chances to get the modulus of elasticity. So, here we are using the proportionality constant in between the stress and strain. So, if I want to remove this proportionality constant, immediately I will get sigma, that is equals to E into epsilon, where this E is called as Young's modulus of elasticity. This E is called as Young's modulus of elasticity. So that whenever we are going to conduct the tensile test for any type of material, on that time we are able to know what is the stress, what is the strain, and what is the Young's modulus of elasticity of constant. We can able to know with the tensile test which is conducted on the universal testing machine. So, this is the one of the simple stress. So, that is tensile stress, which will be helpful to know the strength of the material. And also I want to, this is tensile stresses, right. One more stress will be there, that is compressive stress. So, compressive stress is also called as one type of the simple stress. So, here what is the difference between the tensile test to compressive stress? So, here same bar I am taking, this is the bar element, okay. So, in this, here I am going to apply the force, again same in two equal and opposite directions, but here my way of force is whatever the force I am going to applying here, that is two equal and opposite pushes. So, here also at somewhere we will get some internal resistance, okay, which is offering in the body. So, therefore, that due to that internal resistance of the body, here we can call it as compressive stress, whatever the load which is acting per unit area of cross section. So, we can define as compressive stress. Then what will be happening if I am applying the two equal and opposite pushes? So, whenever I am applying the two equal and opposite pushes on the bar element, there may be a chances, this is called original length of the body, right. So, whenever I am applying the two equal and opposite pushes on this body, what will be happening? So, therefore, the amount of the body will be decreased, okay, due to the elastic limit, whatever the properties, okay. So, due to the properties of this material, there may be a chances to decrease the length of the body. So, therefore, here this is called delta L. So, therefore, based on this concept, I am going to represent compressive strain, which is epsilon c, that is equals to again delta L divided by L. So, that is nothing but change in length to the original length of the body. So, this is called compressive stress. So, for this based on this test also, so we can use the universal testing machine. So, we can take any type of material, whether it may be mild steel or any other material we can take, we can conduct the compressive stress. So, so that based on that we can know the strength of the material, how much compressive stress we can act on the particular material, and what is the elongation of the material, is there any breaking point in the material, all we can know based upon the compressive test. So, that is the compressive stress, which is the one of the most important simple stress under the design for the strength. So, to know the strength of the material, this is also one of the stress. And one more will be there, that is shear stress. Shear stress. So, completely then what is the difference between the normal stresses like tensile stress and compressive stress to the shear stress? Means here we are applying the load on the bar elements, okay, so axially, but here where in case of the shear stress, the major difference between the normal stresses to shear stress is, here we are going to apply the load in the tangential direction itself. So, let me take one bar element simple again. So, this is the like a riveted joint we have taken. So, here I am applying two equal and opposite directions where the force which is acting tangentially. So, here I am applying the force, tangential force. Therefore, what will happen when I am applying the two equal and opposite forces in the tensile and compressive? So, in the one case it is elongated the bar, in the another case it is decreased the bar element. But here in case of the shear stress, what will be happens if we are applying the tangential force? Means here whenever we are going to applying the tangential force on the element, so here the bar may be teared off like this. The bar may be tear off like this. So, that means the position, so half of the position will get here and half of the position will get here due to the application of the tangential load. So, therefore, here whenever we are applying the tangential type of stresses on the body, so on that time we will get the shear stress and also shear strain, which will be represented with tau, which will be shear stress is always represented with tau. So, here whenever I am applying this type of force shear stress, therefore tau, so always we will get the shear strain. So, here also we can, here we have represented Young's modulus of elasticity, therefore, here we can identify the modulus of rigidity, which will be represented with letter Z. So, modulus of rigidity is nothing but whenever the shear stress which is directly proportional to the shear strain. So, therefore, theta, therefore, tau is equals to Z into theta, where this G will be called as what we call modulus of rigidity. So, these are the different stresses called as simple stresses, which we are going to applying on the particular any type of the material. So, on that time we can know the material strength. So, whenever we know the material strength, we can go for the design. So, therefore, in the design, the main role placed upon that application of the load itself. So, then what type of load we can apply on the materials means, or else whatever the type of can call it as the shock loads, okay, maybe axially loaded loads, radially loaded loads. So, we can apply, so depends upon the direction, depends upon the amount of the load, we can apply the n number of type of loads, but our ultimate aim is in order to propose the how much strength that particular material which is having, that we need to specify. So, therefore, how we will specify the material strength means based upon the conducting the number of experiments to the material. So, by using the universal testing machine, in the college level we will use the universal testing machine. So, we can use the material, we can place that, we can conduct the n number of tests repeatedly, ultimately we can specify the strength of the material. So, after that, after knowing the strength, we can go for the design, and after that we can go for the fabrication. So, for each project whatever we are going to we are going to taking in case of the design. So, therefore, we need to do this type of experiments. So, after that here design, whereas coming to the design we have n number of types of design. It may be a adoptive design, or it may be a development design, or it may be a new design. So, what is mean by adoptive design? Already someone will do the experiment and they have given the some specification. So, just we adopted that design and we are giving the minor alterations to that design, and we are proposing the another any specific point. So, that is called adoptive design. Whereas, coming to the development design, it is also existing from the existing design, but after completion of the all the experiments on the design, completely it can be a new design. Therefore, that is called development design. Whereas, coming to the third type of design, that is called new design completely. So, where new design is nothing but here always it is the new. So, no there is no adoption of the designs, just completely new, and we have to give the new equipment to the society. So, that is called new design. So, based upon these parameters, whatever the design we want to do and what type of material is required for that particular design. So, how we have to select the materials, what properties we need to select for that particular component design, and how much we need to give the strength for our requirements. All these analysis should be required in order to design the particular component. So, after that, this is the one parameter such that is called design for strength. Thank you.